everyone. So we're going to talk a little bit more about OpenRefine and kind of what OpenRefine can do. As we've seen, it already allows us to get a really quick way of kind of getting a subset of data. So if we do a text facet on our station ID, we can very quickly subselect just a certain start station. Just a couple of clicks with that, we automatically have a count. If I wanted to create just this subset, I could quickly export it, and this will preserve my original data set. So that's the other thing that's nice. You don't really need to worry about saving with OpenRefine. It's kind of, at least once you've opened a data set, it's basically there for you to go back to. So I want to talk a little bit about some of the things. So what we did just before concluding last time is we converted our trip duration to numbers, and our start time and stop time to dates. Now, one of the things that we can do is when we do this start station ID, we're calling this a text facet, right? And that's because although technically this is a set of digits, it doesn't matter that it's a number, right? Like there's no meaning to summarizing these in a numerical way in the way that, for example, there is with trip duration, right? So for trip duration, I might do a numeric facet because I want to see what the distribution of numbers is. And what I can see quite quickly, and what I want to point out here, is that what we're seeing is actually the entire data set in this numeric facet. What it's trying to do is it's trying to show, there is a small highlight in here that's trying to show only the segment that applies to our selected start station. It doesn't work very well because this is such a skewed data set that in fact we can find out very quickly that only 39 rows are over 100,000, but we have some that go up to over 2 million, right? So people who actually, in this case, kept the city bike like the entire month or for a few weeks, right? So this histogram, however, is exactly what we would create in order to generate a distribution, right? To see what the shape of our data is and determine whether or not it is regular or standard or not. Now, so this is sort of like, it's like kind of interesting, right? We know that 99,961 of our data points are between 0 and 100,000 seconds. Maybe that's not quite so interesting. It might not be how we look at it, but we can see other things. For example, if I do a timeline facet on start time, start to get something a little bit more interesting. Now, I just sort of arbitrarily chose the first 100,000 rows. And if we were to look at a subset of this, right, what this is doing is I've got about 2.5 days of data here, right? Goes over to, if you look here, September 3rd. And of course, this is a 24-hour clock, so midnight is at 00. So for example, if I look at something like September 2nd, this actually looks like it might be almost a standard distribution, right? Like people are not getting bikes so much late at night. But, you know, during the main part of the day from about 6 or 7 o'clock until about 8 o'clock or 9 o'clock, right? You know, there's a peak in the middle, right? And a drop off. Contrast that with September 1st, right? Which if I start at just after midnight and go until just after midnight, right? Looks a little different, right? I wouldn't say this is perfectly reflective of this, but it looks something like what we might call I think it's binomial distribution. I'm forgetting the word. I think it's binomial. Basically, a distribution. It's sort of like two overlapping standard distributions, and so you sort of see two. It's like the camel's hump, right? So you sort of see two peaks in a valley. A little bit, not entirely, but it is potentially worth thinking about, well, there's this huge peak, and at what time is that? Well, that's between 7 and 11. If I go in a little bit closer, even, I can see it's really more between like 8 and 10. If I come over here and I look at sort of the highest point here, I will notice that that is between 5 and 7. Now, if we go to our calendar, we will be reminded that September 1st was a Friday, aka a business day, and September 2nd is a Saturday. So one of the things that we may find that we could hypothesize is that actually on weekends, people use city bikes in a pretty normally distributed way. The peak time is sort of in the middle of the afternoon. And this might tell us something about, for example, who's using them. So, or this might lead us to question who's using them. So one of the things that we have here is we have subscriber versus customer. So one thing we can do is we can text facet on subscriber versus customer, and actually we see that even in this we have quite a lot more subscribers than customers. When I choose subscriber, you can see that it's showing me this this sort of highlight within that histogram. So what it's showing me is, interestingly, is that among subscribers, it's almost a perfect standard distribution of selection during those times. If I flip over to customer, what I see is something very interesting, which is that it's still pretty much normal on that one day, but very different pattern if we look at the work day, right? If we look at that Friday, doesn't match at all with the patterns of use that we see among subscribers, right? And so subscribers, of course, are people we might hypothesize are regular commuters, right? People who depend on City Bike as part of their morning commute. So we can start to see how by making these sub-selections and these filters through our data, we can start to see patterns, right? We can start to hypothesize about what's happening when and why. So this is a really powerful aspect of OpenRefine. Again, this is not dissimilar to what you can do with pivot tables. I like OpenRefine because I find it a little bit more intuitive. I like that it deals with large volumes of data. I also like that it's open source. It's a personal preference of mine as well. But I also want to highlight some other things that it does that are really helpful. So in addition to the exporting, which I really like, is that OpenRefine allows us to do a bunch of actions on cleaning up our data and also documenting our data automatically, which is nice. So for example, to look at the documentation, I'm just going to X out of this now. To look at the documentation, you may have noticed that there's something here that says undo redo. Now, if I click on this, what this is showing me is all of what I'm going to call the meaningful actions that I have performed on this data set since I opened it. Okay, first I created the project, then I did a text transform on 752 cells. So if you remember, I transformed first just station 519's trip durations to a number, and then I said, oh no, wait, I'm going to do it to all of them. That's number 2. Number 3, I did a text transform on 100,000 cells, in this case my entire data set, in the start time column to a date. I guess I accidentally converted stop time to string, which didn't take, and then I did it again to date. Now, what's the point of this? Well, first of all, as you can see, this is helping record, this is helping keeping track of what we've done to this data set, right? So it helps us with our documentation process, which is always great. Even more than that, what it does is we can actually extract this as, guess what, a JSON file. Now, why does this matter? Well, let's say I had made a bunch of adjustments to this data file. I might have done even more, right? I might have done some additional editing or sort of cleaning up of the data. And, whoops, my window is acting weird here. There we go. Sometimes that window size is not quite right. Sorry about that. One of the things that we can do here too is we can do something called cluster and edit. Okay. Now this isn't going to be super useful in this particular instance. Where it's really going to be powerful for us is where we have messy data. Okay, data that has been entered by hand. By someone, by people, because it tends to have a lot of inconsistencies. What this does is this uses various types of kind of natural language processing on the data, and it says, hey, these things look similar. Do you want to make them the same thing, right? Now again, because it's a systemized data, we actually don't have a lot of these. We don't actually want to collapse any of these together, really. We know that they are distinct, but if there were misspellings in here, we would have an option to say, oh yeah, I want to merge all of these together. Now, the question of which of these you use really is just dependent on which ones produce the results. I mean, they do technically do different things. The metaphone and phonetic are exactly what they sound like. They depend on the sort of word sounds. N-gram has to do with a more distinct format, whereby it's actually looking at the sort of the words in sequence. In any case, you don't really need to understand precisely what these are doing, but they are really helpful when it comes to trying to clean up messy data. So that's another really powerful thing that this does. What this means is that if I had done something meaningful, let's say I had cleaned up my data a whole bunch, right? I found a bunch of misspellings in the data set, and I've made all of these things. All of those would appear in this history, okay? So apart from the fact that I have a strong commitment to documentation, what good is this? Well, as we know, this is data that gets released periodically. And something like even what I've done here, which is to say that I want to, first of all, this is something that I can step back through. So let's say I did something I didn't want to. I can actually use this as an undo function, okay? So I can, just as it says undo, redo, I can step back through the actions that I've taken without penalty, right? So I don't have to have like apple Z, right? And hope everything goes okay. I can see exactly what was done when. And so, for example, I might come all the way back to the beginning of the project and say, actually, I want to go ahead and make sure that I do this conversion, this transform on all of the cells right away. So I'm going to say, okay, to number. And you can see it's now replaced that history, right? Because I had stepped back, it's saying, okay, wait, go back to the beginning, start over again. So now I'm going to do this again. And the point that I want to highlight here is that if I were to open up another copy of this file, or for example, another month of data, I'm probably going to want to convert the trip duration to number. I'm probably going to want to convert the start and stop time to a date. And the way that I can do that most easily is actually by running this exported file against a new data set. So just to give you an example, I'm going to extract this, okay? So I'm just going to do copy. Okay, and I'm going to go ahead, and again, I'm on a different computer here, so, oof, what a mess. I'm going to have to search for my text edit file here. Oh boy, yeah, this is the pre-setup version. No, I just want programs, people. Oh man, okay, this is really annoying. Let's go with this. Maybe sticky notes will do this. Okay, so a really annoying way to do that. But anyway, I've got a copy of it saved. So now I'm going to go ahead and let's say I wanted to look at a new data set. So I'm going to go back to, I'm just going to click here. Okay, and you can see here is the first version that I've done. Now, if I want to create a new project, I can say, okay, I'm going to actually pick that same city bike trip data, but remember, I only looked at the first 100,000 rows. So if I want to look at the next 100,000 rows, I'm going to click next. Okay. And what I'm going to say is, well, first of all, yeah, I want you to keep the header row, but I want you to discard the first 100,000 rows. And I want you to load at most, 100,000 rows. And I'm going to say city bike second 100, okay? And create project. Now what this is going to do is exactly what I wanted, which is I'm now looking at the second 100,000 rows of data. And if I want to reapply those transforms that I did, so I want to do that convert to number, convert to date, again, it doesn't seem like a big deal right now, but as you start to do more complex activities in these data sets, it's going to make a bigger difference. I'm going to say, look, I want to apply that JSON file. Okay, so I could have just left this on the clipboard, but I pasted it in from the other one. I have to keep zooming out because of the way this goes. And I just click perform operations. And voila. Okay, I have done this to a very extensive degree, and it's incredibly useful. So that's a quick overview of Open Refine. We're going to look, as I said, at regular expressions starting next week, and of course discuss the readings in class. But if you have any questions, please post them to Piazza. See you soon.